webinar. Yeah, we've got Ben White from the Kondinin Group joining us to talk about the iHSD and the Seed Terminator. Ben was on the road at harvest time last year having a look at these machines in operation, and he is going to tell us what he found and really focus probably on some of the operational issues to do with those machines. And today is a little different in that we also have Judd Wheatley and Nick Berry in the background. So Judd obviously being from De Bruin Group, who make the iHSD, Nick from Seed Terminator. They will be in the background listening in. So if you have specific questions for them, please put them in and they will be able to text in the questions, the answers, and I will read out the answers to those questions. Also, just a reminder that WeedSmart Week kicks off in Narrabri on the 20th of August. We have a one-day sort of seminar and 2 days of field trips. So check out WeedSmart Week on the WeedSmart website if you haven't done so already. Anyway, enough from me. We'll hand over to Ben White now from the Kondinin Group. Good morning, Ben. How are you?
Yeah, I'm well, thanks, Pete. How are you?
Yeah, good, mate. Yeah, thanks for joining us. We wanted to talk about the HSD and the Seed Terminator, and you being the man who went out in the field and had a look at these machines in operation last harvest and did a Kondinin research report on them, we thought you were the perfect man for the job. So,
yeah, I don't know. We probably raised a lot of questions and provided a bit of info as well, Pete. But yeah, more than happy to have a chat about what we did do at harvest last year. Effectively, we did a lot of miles and got around and saw as many owners of iHSD and Seed Terminator units as we could, and there's about 20 in total. And we looked at what crops they were harvesting, machine and performance data, gathering as much of that from the telemetry of each machine as we could. And we sat back and analysed that and just poured through the numbers. And typically that involved following up quite a few farmers with a lot of phone calls. So big thanks to all those farmers that we spoke to at the end of last year. They certainly were very helpful, as were you, Pete, in terms of providing a lot of information. As well as that, we also then put some of the questions that have been raised to manufacturers, and to their credit, they both came back with some terrific responses and really detailed explanations, which we published in full in the report, we think that that's pretty important. So that's all included in the report, and I think, Pete, at the end of this webinar, we'll be talking a little bit more about what's involved in getting a hands on a copy of that. I'll launch. I think we might have lost Pete there, so I'll just launch into what we found. Firstly, we'll look at the iHSD, obviously distributed by McIntosh, manufactured by De Bruin, and we've got 2 mills there running in alternate rotations, that is counter and clockwise. It costs around 160 grand fitted. The mill design, you've got rotors and stators, as you do with all of these mill designs. And I should note that this particular stator here is pretty heavily worn. So, moving on, just in terms of the drive system for the iHSD, we do have a separate hydraulic system here, and you can see that the hydraulic drive is completely independent, therefore requiring a separate hydraulic cooling system as well. So, moving on to the Seed Terminator, we've got obviously a mechanical drive system, and we've got rotor. The mills themselves rotate in the same direction. So, looking at around $120,000 fitted, as I mentioned before, obviously mechanical drive. So that's the main difference in these two. As we saw them last year, that could change next year potentially. And just looking at the actual mill design on the Seed Terminator, you'll actually see the hammers here in the centre of the mill, the rotor screens, and then you can also see here the stator screens, which are adjustable, which means you can position those to vary the aggressiveness. So, Pete, have we got you on board there?
I am here. Can you hear me?
I can indeed. Yep, no worries.
You're going well, mate. If you just keep going, and if I have any questions, I will chip in.
No worries. Look, I think what we did do in terms of gathering some of those observations last year, we spoke to a lot of owners about their experiences and also the results that were coming out of the machine. Now, while we didn't, gather samples and do germination tests, etc., anecdotally and visually, the results are pretty comparable. And I do believe that there are numbers to quantify that now. I do suppose that if we do see variations in mill design in the future, it would be really great for each of those designs or upgrades to come with, I suppose, some certainty that that kill fraction and efficacy is where we need it to be. So that's probably something I'd be looking for in the future, and I'd be interested to hear from both Judd and Nick as to whether that's planned or has already been done. I suspect in some cases it already has. So.
Well, I'll put that question out there now, Ben, to Judd and Nick, who are in the background. If they want to chime in, they can probably just type in the question box with an answer, and I will read it out. Just what kill rate are they finding with their test results? And what are they aiming for, I guess, to sort of stay above? What percent kill rate of weed seeds are you hoping to stay above, and what are you getting at the moment?
Yeah, that'd be great.
So you keep going, Ben, and when that comes in, I'll interject again.
Yeah, great. Thanks, Pete. Look, this is the sort of result we're seeing on the ground, and as I said before, visually the results are pretty comparable. Certainly a lot of dust as well, and we will raise that as an issue as we go along. So a couple of issues and proposed solution, perhaps a common to both. Dust is most certainly a problem with these setups, and in both cases we saw owners of either machine saying that they had to clean out dust filters a lot more regularly. Air filters blocked up almost daily, and filter alarms are going off with an increased frequency. There were a couple of modifications that a couple of farmers had put in place themselves. That was just diverting some of that airflow down so that it wasn't pushing straight out and then getting stirred up with airflow coming off spinners or spreaders and or wind. So just keeping that dust down on the deck. Mill life was obviously a problem for everyone, and that was obviously more apparent in areas that had high sand or lots of sand soils that increased that wear rate. Foreign and metal objects were a problem for a couple of, certainly a few growers last year, and in some cases did cause a few fire issues. So I should point out that in most cases that was due to a mechanic leaving a tool inside the machine after doing some work, or in some cases a piece of sieve getting belted out through the mill and getting obviously pretty hot in the process. So that was a bit of a drama. And then maintaining that straw and chaff separation was also pretty tricky, and obviously we're trying to keep that straw flow out of the mill so that we don't get increased wear, and also we don't want bridging over the top of the mill. What ends up happening is you get a plug of chaff then just jamming up the mill, and it's a bit of a bugger to get out by all accounts. If we look specifically at each of the machines now, what went wrong last year, we saw some issues with the tape roller bearing preload, heat and failure with the iHSD. Software and electrics were a bit of a problem for some owners. Heat dissipation, that cooling package, looked to require some work to improve efficacy, and we did also see some uneven mill wear. Now, Judd will probably be pretty keen to give us some more details, but I do understand that that the bearing has been changed. There's been a fair bit of work done on the cooling package, just in terms of placement and trying to keep that cooling package working as efficiently as possible. And I believe there's also been some changes to the both the metallurgy and the design of the mill. So we're keen to hear some more details about that, and I do believe that it's about to go into some field testing. In terms of the Seed Terminator, there was probably the main issue that we heard from people was despite having obviously a much more efficient driveline, power use was higher than people expected, and obviously that has a capacity cost. Mill life, we did see some pretty high wear rates again in sandy soils, and also that service and backup network continues to evolve. In terms of overall, sorry, I'll just pop back one step there. In terms of Seed Terminator, I do believe Nick's done a fair bit of work during, let's call it the off season, looking at reducing that power draw, and I understand that we're looking at about a 30% reduction in power, and whilst maintaining at 90%, 96% efficacy. I'd be keen, you might be able to again confirm that in his response to the other question Pete put to him. So,
can you just clear that up, Ben? What was specifically the question there?
Yeah, so we're just talking about that efficacy rate. So we've got a change obviously in the mill with that, it's delivering a 30% reduction in power draw, and I understand Nick is reporting a 96% efficacy rate with that change in mill design that's delivering the more efficient performance. So yeah, we'll be keen to hear from Nick, just to confirm that.
Okay, I do have some answers from earlier on. So right. At the moment, and I think I've got this right, Nick is saying that they're achieving 96 to 97% kill at a range of speeds, and Nick is happy with being above 90 or 92%. That's what he aims to stay above. Nick, if I've got that wrong, you can correct me. Judd has responded. They do all their testing with the University of Sydney to verify the kill testing on new mill designs. Results pending not far away. So they've got a new mill design and there's some more testing results that will be out soon, and expected to achieve better kill than the previous mills. Now, let me just have a look here. They aim to maximise the kill in the mills to be greater than 93% and maximise throughput. So that says to me that both mills are in the same ballpark.
Yeah, very good.
I suppose there's another question, Ben. Someone else has come in with a question. With the extra dust created, is the fire risk increased heavily with harvesting bulky crops and perhaps say a chickpea crop? Yeah, not sure if you've seen any fire risk and any particular fire risk for particular crops.
Look, dust dust and trash build-up are the #1 causes of harvester fires, Pete. So I'd suggest that, look, some more regular clean down would be absolutely required when using these, when using a mill. So hygiene's #1 in terms of reducing harvester fires. So yeah, absolutely something you'd need to keep on top of as well.
So farmers are blowing the machine down more when they have one of the mills fitted?
Well, they would need to, yeah, that's right. Yep. Now look, I haven't seen a mill operating in chickpeas, but I'd reckon that would require some pretty serious vigilance in terms of keeping an eye on that dust build up around the place, and what we end up seeing happen is incendiaries popping up off the exhaust and down into the crop or trash, and that's where your issues sort of start. So
yeah, there's one more comment from Judd Wheatley here. They have their new bearing arrangement. It's been tested, and they're sending a machine off overseas for field testing in July. So they're making use of the northern hemisphere harvester by the sounds of things there.
Yeah, good stuff. Yeah, great. Pete, if you'd like me to keep going, I'll pop now onto sort of costs, because I think that's something that people need to be aware of. Obviously, there's the purchase and installation costs that I've already outlined earlier. One of the costs we did ask a lot about was fuel use, and of course, in I think 3 out of 4 instances, machines had been remapped. So, as I said before, despite those driveline differences, we did see some common results in terms of fuel use. It'll be interesting to see how that changes this year. And I suppose the additional fuel use was noted to vary both with crop and yield, but as a rule of thumb, we typically observed 1.5 litres per tonne in a wheat crop. That's the additional fuel use that you could expect to see in that harvest environment. One thing we did also note is that specific fuel use did improve with a remap. So a remap, it would seem, is almost an essential requirement if you're going to fit one of these mills, and that will probably set you back around $4,000. Now, of course, there are potentially some warranty implications with that that people would need to take into account. So
Ben, just to be clear, that 1.5 litres per tonne of fuel, is that both mills were using about the same amount of fuel?
That's correct. Yeah, that's right. That's over a pretty wide range of crops across the country, and yeah, that 1.5 litres per tonne, yeah, as I say, is in addition to base fuel use of machines we observed operating without a mill. Yeah. Cost of mill wear and maintenance. It's a little bit difficult to put a finger on. Normally, we've put that down as $1.75 per tonne in wheat. It does have, there are a lot of variables there. Obviously, crop type, whether there's a soil load, and of course yield does make a difference. Higher yield, obviously you're going to potentially wear mills quicker. Interesting that we do talk about mill life in hours. The reality is that, as I see it, it probably would be better to be measured in tonnes of, say, wheat as a baseline. That's something that will probably evolve in time, I think, once we get used to it. But you can see that that mill in the image here is pretty heavily worn, and that's after 305 hours of mixed operation down at Lake Grace. So they were keen to go back out with that mill component. I suggested pretty strongly that mightn't be a good idea. It was getting pretty late harvest, so yeah, I think people were getting a bit toey.
So that's an iHSD mill, that one, Ben?
Yes, it is. That's right, correct. And you can see a little bit of wear just near the weld, and potentially some metallurgy issues there. I think Judd has identified, and there's a bit more detail in the report about that, and I do believe that there's made some changes to that mill design to accommodate or circumvent that issue. So, yeah, the reduced capacity, as we see, is probably the biggest cost in terms of actual cost of using a mill to implement harvest weed seed control, and if we work on $400 to $500 an hour for a modern harvester setup, and that's typically what we're told by our consultant friends is what we should be using as a baseline. On average, we've seen a capacity reduction between 12 and 20%, and that's after a remap. So that's a big range, but as I said, there are quite a few variables that come into play that can affect that capacity reduction. Look, applying those two ranges of $400 to $500 an hour and 12 to 20%, if we work on, say, 16% reduction at $450 an hour over 2,000 hectares in a 2.5 tonne per hectare wheat crop, we're looking at anywhere between $4.29 to $8.33 per hectare. So that capacity reduction can be huge, and it's something that people need to think about in terms of when they make this investment, what they're going to put it on, whether there's ample power there, and obviously, as I say, I'd work on incorporating the cost of a remap in addition to the cost of the machine, just to try and reduce that or pick up specific fuel use efficiency in the process.
So Ben, with that reduction in capacity, there's a range there. Is there any observations as to how to minimise that reduction in harvest capacity?
Yeah, look, it can vary a little bit, Newms, in terms of the yield. So higher yielding crops, obviously, that specific fuel use drops down. Yeah, as I say, there is a range of variables, and it depends again on whether it's we're talking wheat or barley, or what we're talking about in terms of crop type. I think if we flick to the next slide, that probably puts it in perspective a little bit better in terms of the cost and benefit. If we look at capacity there, we've got it at $2.46. So out of the range of costs there, that capacity cost is calculated assuming a 16% reduction at $450 an hour and 25 tonne per hour capacity. So yeah, the other costs listed there are significant. And I suppose, Newms, one of the things you and I discussed a lot when we were putting this report together was the total benefit potentially in a low-K soil environment, and that at $2.25 compared to the total cost of $7.06 per tonne is a net cost of just under $5 per tonne. And we've used dollars per tonne quite purposely, because we knew that that's probably going to give us a baseline rather than working on hectares and hours. So I think people go in using the cost per tonne, that's probably going to be pretty close to what they end up with.
So can we just pause on this slide for a little while and just
Sure.
go into it? So we've got the additional fuel, the mill maintenance. So I'm guessing that is the replacing of the mills as they wear. Is that the main cost?
Yeah, that's right. And it should be pointed out that not all those mill components wear at the same time. So various components will need to be replaced at various stages throughout harvest. So it mightn't always be the rotors, quite often the stators that need to be replaced, and or in the Seed Terminator case, I've sort of set of hammers that have done a pretty full season and still had plenty of life left in them. So it does, each of those components can be pretty tricky to calculate the costs of, and as I said before, sand moving through the machine can increase wear significantly. And we saw, I think it was down at Esperance, a John Deere track machine actually pulling sand up off the right hand track, pulling that into the machine, and of course that was increasing wear because it had a lot of soil and sand to deal with, which makes things tricky.
So Ben, the one that I'm finding a bit tricky is the capacity cost.
Yeah.
If we $6 a hectare, but below you've got 16% reduction at $450 per hour. Okay, so at 25 tonnes per hour, so that comes back to $6 a hectare. Okay, and then the opportunity cost. Can you tell me a little bit about that number? How you calculated that?
Oh yeah, sure. So the opportunity cost is just the cost of the mill, and let's imagine that that's sitting there offsetting your overdraft as opposed to sitting on the back of your machine. So there's an inherent cost at what do we work it out at? I think about 5% Newms in terms of the value of money over time. Yeah, that's right. So that's just been applied as well. So.
Yeah, and when we talked about that benefit, we were talking about the nutrients really over, say, something which is like a chaff cart or a chaff deck or something like that. And I'll just clarify there, that $2.25 per tonne, that is actually half of the nutrient value, because we know that you don't get 100% of the nutrients back, but that is a rubbery number, that half. So you could say that it is $4.50 benefit if you counted all of the nutrients in the residue that you're redistributing. It is, look, it's a rubbery figure.
Yeah. Okay, so
and I suppose there's a question there, Ben. So is that based on both mills? Given that they come at different capital costs?
Yep, the capital cost is pretty small in terms of its significance. Really, Nooms. We've got you're looking at about 120 versus 160k, so there's about 40k difference. And as you said before, we're working on an interest rate of say around 5%. And again, this example is for 2,000 hectares of wheat at 2.5 tonne per hectare. So yeah, that's how we've come to our dollars per tonne. So yeah, I think we might have split the difference there by the look of things for our $1.20 per tonne in between the costs of the two. So yeah,
okay.
I'd probably be more worried about the capacity cost here more than that opportunity cost, I'd suggest, Nooms.
Yeah, okay. Now I've got a couple more questions and answers here as well, Ben. So
sure.
Now, just going back to the dust issue, Judd came in and said the additional dust created has to be managed by venting away from the header. It's not desirable, so they're working on ways to vent dust away from the header. And so, yeah, that's just another thing on the drawing board of things to improve on. If Nick has any comments about dust, he can come back as well. Let me just have a look.
Sorry, just while you're finding that next one, Nooms, there was a couple of farmer mods, as I mentioned. One just redirecting some of that airflow off the mills just downwards. So it was pretty simple. It was some sheet metal screwed to the top of the mills that just diverted that flow down a little bit. And according to the owner, it made a big difference. So.
Okay, yeah, great. And there's also a question here, is the nutrient value assuming that the chaff component would be removed if not using a mill and say, i.e. burnt? Now, I'll answer that one. It is not necessarily burnt, but if we put chaff in a chaff dump, or even if we put it in a chaff line, with the chaff line, while we haven't removed that chaff from the paddock, we have redistributed it from the whole paddock back into a small zone. So we are saying that it is a loss. Nick has also said in terms of dust that they direct the right-hand side further towards the back, away from the engine rotary screen. And so that is... yeah, that's one of the things they're working on to minimise dust and fire risk. And also one of the other benefits Nick has pointed out that we don't talk about is by retaining all of the residue, we are retaining a little bit more moisture near the soil surface, I guess. So obviously the more residue we can retain in a system, the more moisture we can keep near the soil surface for you know, allowing seeding to go ahead, I guess. We know that the whole topsoil dries out over summer. The top foot will dry out regardless, but it's when you've got good moisture retention just near the soil surface at seeding time when we can really benefit from all of that residue. All right, so that's enough from me for a minute, Ben. I'll let you keep on going.
No worries. I'm just going to pop down to a bit of a summary screen now, Nooms, in terms of a bit of a wrap up. Yeah, obviously there is a fair bit of work being done on both machines to refine design, reliability, and performance. And I think, as I said before, it'd be interesting to see how machines perform in this current or coming season. Hopefully we get some good rain and some decent crops to get those stuck into during harvest. But certainly it'll be great to see some of those reliability issues addressed. It sounds like both parties are working pretty hard on that, as well as from a performance perspective, just trying to reduce that primary cost, which is the operating and capacity cost. So both of those things, seeing a fair bit of investment in time and money. Look, there are some other patents in play, and in fact, I think if you do a bit of a search, there's 3 or 4 different chaff management options that float around the patent lodgements around the world. There's no doubt that we'll probably see some more players in this space. I do obviously think that there'll be some teething issues likely to come with the emergence of any new players, and it'll be interesting to see how or what approach others take on this front. as I mentioned before, the major cost is capacity. So seeing these things do their job, maintaining efficacy at a lower power draw is going to be important in terms of their ongoing development. And the other thing I'd point out is things don't always go right. You know, if we've got some green canola, it's absolutely essential to have some sort of bypass, I feel. You know, where you know you can maintain or continue on the harvesting process and not use the mill in some options. So you just got to have that fallback option, a bit of a you know, lowest common denominator, so to speak, in terms of being able to still perform the operation and get on with the job. You know, we've talked a little bit about that nutrient benefit. I was probably a little bit surprised how low it was, and I would say that technology will continue to improve, and I think growers will assist in that, as they have done. And I think both manufacturers probably agree they've had a lot of feedback from growers as to what they want to see. And I think that's going to be pretty important in terms of achieving the sort of product we want to see. Growers will let you know pretty quickly, and I think they're pretty generous in their time in terms of testing product and providing feedback to manufacturers. So I don't see there's any question about efficacy. As we've heard from both manufacturers, we're sort of talking at 96, 97%. And so I think, you know, we've just got to balance that with capacity. So provided we're overall reducing the seed bank, we need to make sure that we can still get on with the job. And I think that's going to be pretty important in terms of increased uptake. And I think a lot more people will probably look at this technology if they can be assured that A, it's going to be reliable, and B, it's not going to slow harvest down too much for them. We're all happy to handle a few issues at harvest. I think if it, you know, throws a spanner in the works, so to speak, and we have to pull up stumps and wait days for gear to be back in action, that's when frustration levels rise pretty quickly. So it'll be important that that's addressed. And I suppose, Newms, you know, the full report's there on the WeedSmart website for people to download and read.
It is, Ben, and we will get to that in a minute, but we have some more questions and comments. And everyone listening in, Ben's finished his formal presentation, but if you have questions, now's your time to put them in. Now, I would like to explore the capacity issue a little bit, and there is another question about it. But firstly, in the past, I've commented that if a farmer is harvesting at full capacity of his header, let's say there's no mill fitted, there's nothing fitted to the back of the harvester, and they are harvesting at full capacity, I've commented that I believe that headers have more horsepower than sieve capacity these days, and therefore they would be throwing grain out the back. Firstly, Ben, am I right, or is that it depends sort of answer?
It does depend a little bit, Newms, and I think you know, we've all been pretty guilty of pushing the right hand forward a little too hard and pushing harvesters through crops faster than they can probably process it. And obviously, as you say, we end up throwing a fair bit out the back because we're just not getting enough material either threshed or over the sieves before it goes out the back. So you're right. I think that we've certainly seen you know, a lot of grain potentially lost, and I think you've done a bit of work in canola and certainly the work we've done with harvesters in wheat, that loss tends to be exponential as we increase speed. So well, I think we're doing a good job sometimes and getting through things pretty quickly. We could be throwing, it could be half a tonne hectare out on the ground, and again, it depends on the conditions and the machine setup particularly. But certainly, you know, the power side of things can give us a false sense of security, and we can tend to harvest a little bit too quickly. I think one thing about the mills is that they rob a fair bit of that power, or quite a lot of that power, and so we are still looking for it to operate efficiently as efficiently as we can. So, hence the requirement for a remap.
Yeah. Okay. So a little bit further to that question, when you tested it in the field last year, and you're comparing the iHSD or the Terminator to other headers, were the other headers, were they operating at the full extent of their capacity? Because what I know, a lot of growers sort of go, oh, I know my header can do 40 tonnes an hour or whatever, but I like to harvest at 35 just so I'm not pushing the system. Like what happened in the field where you were doing your testing?
Yeah, so we actually had 2 machines in the same sort of crop. Operating would be 15 k's from each other. Yeah, and look, we were seeing, we were looking mainly at fuel use and also capacity and throughput, and that's largely where I guess some of those capacity figures were confirmed. 2 machines, almost identical setup, comparable crop, same variety, all that sort of stuff was so all those variables were taken out of the picture, and the capacity numbers that we're seeing come out of both, yeah, were pretty interesting, and I guess verified, as I say, the numbers we had collected from across across the country last year. In terms of were the machines that we used as our baseline figures operating as efficiently as possible? Yep, pretty much. Very certain of that, and certainly the operators we observed who didn't or who weren't using a mill, you know, were getting out doing spot checks for losses as well, which is obviously pretty important to do. I would point out, Newt, that some of the numbers we've also gathered were off a harvester operating with a mill, and that same operator in the same paddock with the same harvester operating with the mill running. So effectively bypassing the mill for half a paddock and using the mill for the other half of paddock. So yeah, pretty confident in those capacity numbers we've got there.
Okay, so I want to just keep on about this capacity thing a bit. It seems to be the big issue. So another way of asking that question is, say I'm a farmer who has a header that can do 40 tonnes an hour, but I say, look, I like to run it at 35. Mm-hmm. If that farmer fits a mill, will he still be able to harvest at 35 tonnes an hour, if you know what I mean? So there's essentially no loss in capacity because that's how he normally operates.
Well, it's probably, you know, if we're talking about a, you know, let's say anywhere between 12 to 20% loss in capacity, we're probably going to see, sort of down. They'll be down around the 30s, and operating machine at full tilt. You know what I mean? So okay. Where they would, you know, if the best they could get out of that machine was 40 tonne an hour, they're probably going to see, you know, anywhere between 30 to 33 tonne an hour. Again, operating at full tilt. If they like to operate at 35, they're probably going to see somewhere around, it could be 25 to 28. If they want to run the machine at the same sort of power draw, and that's where, you know, the requirement for a remap comes in, so that they can regain some of that capacity and still not run the machine off the chart, if you like. So yeah, still with a small buffer.
So, and there's been other people come in with questions. So is some of the major costing capacity to do with the size of the header, the horsepower that the mills are going on to?
Yep, yeah, absolutely. And I suppose when we look at a lot of Class 7, Class 8 machines, you know, they're almost identical in terms of their setup. The only thing that's different is the fuel map that is loaded onto them. Now, that's not always the case, but you know, in a lot of cases that's correct, and so where we see that, you know, we see a machine that's say a Class 7 with a remap might venture into what we would consider a Class 8 sort of territory. All the threshing system's still the same. If we get up into, say, your Class 10 machines, some of those specifications do differ. So I suppose if you are thinking about going for a mill, make sure that you've got some room in the system. You probably don't want to go for a harvester that's got an engine that's almost running at full tilt, you know, unmapped. If it's mapped, there maybe not a lot of extra power that can be drawn out of it. So, and of course, as I say, you know, we've got to consider the warranty implications of all of this too.
Yeah. Yeah, okay, well, it's another issue, can of worms. Maybe we'll comment on that in a minute. Yeah, just on the capacity issue, Nick Berry has made a comment here that says cost of capacity is the biggest issue in a smaller harvester. He said, we tend to fit smaller harvesters, but potentially going upper class is better if the cost of capital is lower. So the other big cost is downtime. Harvester uptime is the key to ensuring that it is a cost-effective solution. So I guess what he's saying there is, yeah, go upper class, and what they are striving towards is reliability to make sure that you don't have harvested downtime, because that's where, as you already mentioned, Ben, that's a big cost and frustration.
Yeah, absolutely. And look, I suppose just on that point, it would be great to sit down and run some numbers. If we can, if we get enough depth in the data we're collecting to maybe have a look at, the cost of that capacity cost, of a, say, a class 9 machine versus a class 10 machine. And of course, that comes back and would impact that opportunity cost as well, because of these machines, just going up a class, it's easy to say, but it's, we might be talking an extra $150,000, $200,000 in some cases. So, that's on top of the additional mill cost. So, yeah, it'll be great to sit down and do the numbers, and maybe that's something we can come back and do and revisit between here and harvest.
Yeah. Now, just before we get to the warranty issue, Ben, I've got a question for Nick, actually, if he'd like to respond out there. I just see that Seed Terminator's advertised a 30 or a 32% reduction in power. And the question is, have they got their seed testing done on that mill that allows the reduction in power draw yet, or are they, is that testing still underway? That's a question for Nick. But yeah, Ben, the warranty issue. What is the issue with warranties on harvesters fitted with either a Seed Terminator or an iHSD?
Look, so yeah, the manufacturers we approached for comment and all provided a pretty stock standard answer with regard to warranty, and that is that if you play, you pay, basically. And at the end of the day, the words directly from one of the quotes got from one manufacturer was that any warranty issues would be at the adjudication of the manufacturer. So it's up to them. They'll make the call as to whether they'll work with you on any warranty issues. But a couple did say that obviously we're drawing more, we're making the harvester work harder. That could affect obviously the longevity of some components, and obviously that they'd have to then make the call as to whether they felt the mill had increased the wear on those components or reduced the service life. So very much yeah, a case of yeah, from a manufacturer's perspective, a harvester manufacturer's perspective, yeah, we've provided you with a machine with a set warranty. Gone and mucked around with it, so it'll probably be up to us as to whether we adhere to the warranty or whether that warranty is null and void as a result of you doing these or making these changes to your machine.
Yeah, okay, so we've probably got a little bit to find out there in time to come, I imagine, to see what happens when people do warranty claims. That's
right. I don't think it's been tested yet, Newm, so it'll be interesting to see whether that whether that does carry through or not.
Yeah. And Nick has come back to me with an answer saying that, yes, with their mill at the lower horsepower drain, they are achieving a 96% kill. I'm assuming he means ryegrass there. That testing was done at Adelaide Uni. Now, I think I have another question here. What work has been conducted post-harvest in terms of summer spray timings? Pre-emergent herbicide savings, volunteer carryover into following crops, or any of the other benefits / losses arisen from what processes through the mill? So big question there. I mean, we've done a lot of RIM modelling over the years, looking at the value of harvest weed seed control, and I can certainly point someone in the direction of that. But yeah, it's proven very profitable in all of our comparisons. But I guess it raises another question, and Ben, I don't know if you spoke to anyone or heard from anyone, but if we're destroying a lot of the volunteers, does that affect things like mice or just the volunteers, crop plants coming up as a weed the following year, or green bridge, or any of those things? Is there any other sideline sort of benefits that you heard of in your travels?
Oh, look, I think it was one of those seasons, Newms, that we probably haven't been able to reserve any of that this particular year. Certainly, it stands to reason that that would be the case. And of course, there are benefits that we haven't included in our cost benefit analysis, because they're obviously pretty difficult to quantify. But yeah, I can imagine that reduced volumes of food on the ground for the likes of mice, or as you say, green bridge issues that might spring up with volunteers. If we're putting that material through the mill, then we should be getting pretty close. I suppose the one thing that is noticeably important is just making sure that we're getting everything we need to through the mill as well. Newms, pretty important from a setup perspective, making sure that material coming off the rotor and through the spreader doesn't have weed seeds with it as well. So timing's got a bit to do with it, and probably there's some seasonal effects there as well. Yeah.
Okay. All right. Now I think we've pretty much come to the end of our questions and comments. That's great. Unfortunately, I think Judd Wheatley from De Bruin may have dropped out part of the way through with some connection issues. But what I would say is, anyone listening in, or that if you have more questions, we can maybe tackle them via Twitter, and we could, if there's any more questions of Judd or of Nick, let's come back to us at WeedSmart, and we will have those questions answered and make sure that we get them answered. So thanks very much, Ben. That's been a really good summary of both of the mills. It's great that you're the independent person in the middle who was able to do that for us, because you were out looking at both of them at harvest time. And I think it's been a really fair comparison, and the research report that you did, I thought, was very fair to both parties as well. So thank you very much for joining us.
It's a pleasure.
Thanks.
We look forward to seeing what both manufacturers come up with, in the harvest to come, and certainly we'll be continuing to follow the progress. It's a pretty interesting space. I think there's a lot of questions about what people can do and what options they've got. So thanks, Pete, for having me.
Yeah, good on you, Ben. And if Lisa hands back to me, here we go, showing my screen. Here's the plug. So we managed to buy the research report from Kondinin and put it on the WeedSmart website. So thank you very much to the Kondinin Group for making that all possible. So normally, to get your hands on a research report like this, you need to subscribe to Kondinin or go and purchase the report individually. But we thought it was such a good report, and so well done for a range of harvest weed seed control tools. We have organised to put that on the WeedSmart website. So there it is there. If you'd like to have a look at that research report, and I highly recommend it, I think Ben and the team did a great job, go to the WeedSmart website, click on resources, and then you'll be able to see the research report for you to, I think, download or maybe just view online. I'm not sure, but it's there anyway. And thanks very much to Kondinin Group for making that possible. That's all we have for now. Thanks, everyone, and thanks very much, Ben. And please, if there's more conversation, let's follow up on Twitter in the following days, and cover any last questions.
Sounds great.
Thanks very much, Ben. Good on you, mate.
Thank you very much, Pete. Cheers.